Alrighty, so class.
Yes.
Oh, all right. Okay, so now for the people that are here today, thank you very much. Now we are going to, um, we're almost done with all the stuff that we need to do. So we have this one, this section here, and then we're taking the test next week, and then we have like 6162. I'm hoping we could actually get test prep in with that. Um, because we got this Saturday, which is going to be our first one, and then next Saturday is the next one, right? 11th and 18th. I think that's what it says, right? Okay. All right. So going through here, um, you you will want to have your calculator with you. So if you have your calculator, that will be helpful because I got to teach you guys how to do something, and it's something that's so frustrating because it's a weird thing. I have to look it up every year. And that's why I get frustrated about it. Oh, I do have that. All right. So let's go through. It says separate first order differential equations, slope fields, and Euler's method. So separation. We did some of this yesterday where we're separating our implicit. So we have all of our x's on the left and my y's on the right, or vice versa. Separating those to be same thing. So separable, solve a separable first order. So this is going to be some value x comma y where we have m of y, or I'm sorry, m of x over n of y. So what it comes out to be is I'm moving my x's to the right here, and I'm moving my y's to the left. So I'm separating it so I can actually have everything lined up. So it's really not going to make sense until we actually do it. So let's go through. Red. All right, right here. So, like I said, we're going to separate it. So dy dx is equal to 3xy squared. So to get my dx over to the right, what do? Multiply both sides by dx. Right? So over here that cancels. And now I'm going to have dy equals 3xy squared dx. What goes next? Divide by y squared, right? Yeah. Divide both sides by y squared. Now, are my variables lined up now? They're both on both sides. So, to undo the dy, to undo the dx, which is my change in y and my change of x, is so my rates of change according to that, we're going to do the integration of both sides. So, I'm going to go to a new page here. I'm going to rewrite it. So, it's going to be y to the negative 2 dy equals 3x dx. Integrate both sides. So as I integrate the left, what am I going to have on the left? Negative 1, right? Over
y
to the positive 1, right? Yeah, very good. Okay, so there we go. So I have that equals
3x squared over 2.
Am I missing anything?
Plus C.
Plus C. Now, why did I not do the plus C on the left-hand side?
Because they cancel each other out.
They're eventually going to cancel each other out because technically it's going to look like this. Going to look like this. Then I'm going to go like this. I'm going to go minus C1, minus C1. And so it's going to be C1 minus C2 is just going to give me some C3 value, right? Which is, as I combine those, it's still just going to be some C, isn't it? So instead of actually putting it on both sides, we're mentally, right now, we're not going to put it here. We're going to mentally already add it together over here on this side. So instead of actually putting it on both sides, I'm just going to put it to 1 because C is a constant, right? That would be like the number 2. If this is a 2 and this is a 5, I would actually subtract it there. I would get 3. Is 3 in this scenario still just any constant? It's just any constant. So what I'm going to do is I'm going to save myself some headache and heartache and just call it C. Because whenever I add two together, I'm still going to get just some constant. I just don't know what it is either way. Now, on this problem right here, it said find the particular solution. This is working towards a general solution since I don't know what my C is. So it's going to be x is 1, y is 2. So when I have a particular solution, that means I'm going to have one line. I'm going to have una línea. So let's plug those in. So I get negative 1/2 equals all right, let's see. 1 squared is 1 times 3 is 3 over 2. And that's positive, right? So I need to move this over here on this side. I need to move it to the left. So I have a positive 3 over 2 here. So I need to subtract 3 over 2, which is going to give me negative 4 over 2, right? Negative 4 over 2 is equals my C value. Are we okay to this point? Now, I know what my C is, so now I can do my particular solution, which has to do with this one right here. My particular solution is going to include whatever this is. So I'm going to have negative 1 over y equals 3x squared over 2 minus 2. Now, particular solutions tend to not have fractions in it. So they don't have fractions, and they equal 0. So I set it equal to 0 when I do this. So from right here, I'm going to multiply everything by the common denominator. What's the common denominator going to be on this? 2y, very good. So it's 2y. And as I distribute, this is going to be a negative 2. Equals, this is going to give me 3x squared y. And as I distribute right here, I get negative 4y. And what was the second thing I said about that particular solution?
Equals 0.
Equals 0. So that means I need to do what here?
Add 2 on both sides.
Very good. Add 2 both sides. So I can get 0 equals 3x squared y minus 4y plus 2. This is my particular solution. And if you could please, let's get your calculator out so I could show you how to do these. Now, this is the part that actually messes me up every year because it is, when I first learned how to do this, the calculator had to update afterwards, so it has a different notation for this. So, I'm going to go to my graph. And we're going to put our original problem, okay, our original problem, which is our differential equation. So right here, especially for those people taking notes on this, is I'm going to start by hitting menu, graph entry, and down here is my differential equation. Now, you have to pay close attention to the notation we have here. This is y1, okay? y1 prime, right there, that little tick mark right there, right? So that means the dy dx. This is actually the other way of actually writing dy dx, right? Okay, so it's actually y1 prime is equal to my problem, which was 3x y squared, right?
What button do you push against that?
3xy squared.
No. Okay, so you're right here, right? Where are you at? Are you on the graph? Hit, yeah, hit menu.
I don't know.
Graph entry. And you should see differential equation. Diffie Q. You got it? Okay. Make sure you write it down too so you remember. So as I put this in, my original problem was 3, and I'm going to put times here. This is important. Okay? So 3 times x times. Now, the y squared, this is where it kind of messes people up. This is where the notation, which is actually important here. Which y are we talking about? y1. So I need to state that it's y1 because I could do higher order of these where I would have a y1 and I'm doing a y2 problem. So I could actually have multiple to do with that. So remember when we took multiple derivatives of something, when we did implicit differentiation, so I could do your multiple, so we could actually find values as I work backwards. So I'm going to put y1, because I need to notate it which y value I'm using, and I'm going to hit square. The calculator should have this down as saying that this is y1 is all that value. There we go. this is a slope field. A slope field is actually all possible values I could have for my C. Because C is just any constant number. So if I give you an X and a Y, that would give me one particular line in this case. So now I'm going to go right here. I'm going to go menu, graph entry, and our particular solution had an X and Y in it, right? So it had a, you know, what was it, like 3x squared y or something like that, right? Yeah, it had that in it. So if there's an X and Y, we have to put it as a relation. We can't enter it as a function. We have to enter it as a relation. 2, my relation started with, so is 0 equals, was it 3x squared?
Yeah. 3x squared y minus 4y plus 2.
Now, you notice how the slope fields go. Ms. Johnson, do you have a question? Okay, just stretching. It's fine. Now, the slope field basically says all possible choices for X and Y is actually listed on this field here. But if you notice, as I go right here, look at the curvature. Look at how the current is going on the slope field. So if you think of it as a type of river, it is flowing with it. So this is me throwing something, a boat, a stick, or something that's going to float through this. And as this is going, it's curving right around here, right where it starts to curve at. So right here, as the slope field comes around, right here in the middle, right in between -1 and 1, you notice it goes this way. So if I were to have the slope field here at 0, wouldn't that be a flat line right there? It looks like it would be. So this is my particular solution given the whole thing. I could put in other values for my X and Y and actually get a completely different one from there. Does that make sense?
Slope field.
Say what?
Slope field.
Yeah, slope field. Tree, are you ready to test yet? Okay. Test practice is this Saturday. So,
What's the control for the slope field?
what's the what?
What's the control for the slope field? No, like the procedure.
Oh, the procedure, the buttons to push. Do you have the calculator with you?
Can you show me right now?
No, do you have the calculator with you? Huh?
It's over there.
Oh, come get it.
No, this one,
Oh, you are ridiculous. You are. So, instead of staring at your phone, you could have watched this one. I'll do it again. You ready? Okay. So, let's go back and start it over again because Tree is following along now. All right, so from right here from the graph, I start by doing what? Menu. Thank you. Menu. Graph entry. Differential equations. Very good. The original, which was?
3, and then you do like
Times. X. Times.
y1.
Y1. Why Y1? Because that's the one we're using, right? That Y1. Very good. Y1. And that Y1 is? Squared. Enter. Now, I'm going to do this also so you can see this. This is not as accurate. tab right here. So I'm going to go back. I'm going to go back to this. So this is actually another option you could use. We're trying to find a slope field, and I want to make sure it does this. This is an approximation. It just gives you a general so you could draw a dotted line on your slope field. Right here, I'm going to put my x and y for my particular solution. That was 1 and 2. Hit enter. There we go. It estimates it. So if we go back to what we had, these right here are estimating dots as we get near the point, which was right there. Okay, estimation, it's not a good way to actually say what it is unless you have to sketch a slope field. The particular solution is the better way. All right, and then to do the particular solution, walk me through particular solution.
That's menu.
Menu,
Graph entry.
graph entry, relation. That's where I enter that in. 0 equals 3x squared y minus 4y plus 2. There we go. Notice my blue lines and my brown lines don't line up. They line up through the point, which was given right here, 1, 2. But everything else are estimations. So, questions, concerns, complaints, conspiracy theories? Yeah? All right. So, let's go from there. And your homework.